Okay, this tutorial is for factoring and reducing of rational expressions, and it's 4.4 in the textbook. And we're going to look at specifically 3 different kinds of examples that you can get in this area of reducing. Firstly, we'll look at 2 monomials. Remember that you cannot just simply cancel out things without making sure that you're canceling out complete factors. So we'd have to completely factor the top and bottom of these monomials. Factors of negative 25 are negative 5 and 5. 3 x's, 2x, 2 y's, and 3 z's. And here on the bottom we have a 2 and 5, an x, 3 y's, and a z. So now when we cancel out each. So we got a 5 and a 5, an x on each, a y here, a y there, and a z here, and a z here. And then we can see what's left in our example. Well, we have a negative 5 x squared z squared over 2 y squared. And that would be our example. So I'm sure you've seen monomial factoring and reducing before, but that's just a review there. Now we'll look at this example B here, which I kind of wrote there, but you'll notice that when you have something like this, that this is a complete opposite of this. So when you write it out, you can write it out, say, as, you don't have to write it out completely, but this is x minus 1 3 times. This here 1, if we multiply it by a negative 1, we would get same sort of thing. So let's actually expand it first. So this would be this, simply put. Now if I want to convert it into these ones here, into that form, I can multiply this by a negative 1 to get that form. So I can just do that. Leave those and multiply the bottom ones by negative 1. So if I multiply that by negative 1, it becomes minus 1 plus x, or x minus 1. Same thing for this one. So now we can see that 2 of the x minus 1's cancel, and that negative 1 times negative 1 is 1. So our answer is going to be x minus 1 over 1, or that. Okay, I'm just going to move up and check my field of view. And one thing I've been forgetting to mention here in these examples is restrictions here. A restriction meaning that the bottom can never equal 0. So if x, y, or z were 0 in this case, then it would be impossible to do so. Our restriction on this one is x well, in our case there, we cannot have those as zeros. Or actually, I guess we could have a z is 0 because it's not on the bottom. We have to look at the final answer here. Y cannot equal 0. Y. Always look at your final here. And here in our case, we have no restriction in this case because there's nothing on the bottom but a 1 in that case. So we don't have to worry about it. Okay, so let's go on to our next example here. I'm going to move that up and make sure it's in the field of view. So this one was y cannot equal 0. And this one's no restriction. In our third example, let's say we had something that looked like this. Let's say we had y squared minus 25 all over y squared minus 3y minus 10. So we must factor this. Okay, you cannot cancel out the y squareds here and then try to work it out that way and cancel out 5 in each of these. You can't just simply start canceling. You always have to factor first when you have binomials and trinomials. So this is a difference of squares. That's y plus 5 times y minus 5. And this is a trinomial, so we have to find two factors that multiply to negative 10 and add to negative 3. So that's y, in our case, two factors of 10 would be a negative 5 and a positive 2. Okay, so that gives us a possible cancellation here now. If you can see these two are one on the bottom, one on the top, we can cancel. Okay, so then our answer then becomes y plus 5 over y plus 2. And since this cannot be the bottom cannot equal 0, y cannot equal negative 2. Otherwise you'd get an undefined number. Okay, I'm going to continue on and do another example similar to that here. Just check my field of view. And we have y squared minus 8y plus 15 all over here in this case y squared minus y minus 6. So we can use two numbers that multiply to 15 and add to negative 8 for the top one. That would be 5 and 3, both negative. X minus 5 and y minus 5 and y minus 3. And here two numbers that multiply to negative 6 and add to negative 1. Y, in our case, minus 3 and y minus 2. Again, we have a cancellation here. And we also have an answer of y minus 5 over y minus 2. So y cannot equal 2. And that's an example, a simple example of factoring out and reducing with rational expressions. In our next tutorial, we'll be looking specifically at dividing and multiplying and then reducing of rational expressions.